Okay, YouTube, in this video we're going to perform a fairly common task, which is to find the sum of two vectors u and v, but we're going to do it starting off by knowing not the x and y component of each vector. We haven't been given the component form. We're going to need to find them given the magnitude and the direction of the vector, okay? So given the magnitude and direction, one thing I really quickly want to mention again here is this. We have that given any vector in standard position that starts at the origin and terminates somewhere, we just need to find this point xy that it terminates at to write its component form, which we would say that its components are x, y, in brackets here. So to solve for this x and y value here, we're saying if we were given the angle and we were given the magnitude of this we could solve for the angle here. We could say solve for the x value here by saying that the cosine of this angle here is x over the magnitude of this vector v. And so essentially if we multiplied both sides by the magnitude of v, we would yield that x is equal to the magnitude of v cosine theta, or the length of the vector times the cosine of the angle that it makes with the positive x-axis. So the same thing can be said about this value for y, but you'll notice that we say that in general, if you know the angle, the direction angle, and the magnitude of the vector, you could just write its component form by writing magnitude cosine angle and then magnitude sine angle, and that's it. So what we're going to do here is we're going to find the sum of these two vectors, and we're going to try to visualize this first, but we're going to have to find their component forms before we do anything else. So I want to go ahead and sketch this in and say, well, what would this look like in a two-dimensional sense if we were adding these vectors? So we say we have some vector that's 4 units in length and it's going in a 60-degree direction. So I'm going to kind of loosely sketch these in here. We would say, all right, here's my 60-degree direction, and I'm going to say that that's 4 units to me. And I say, okay, well, this other one here, this is going in a 90-degree direction. It's 5 units long. So I have this vector here that's slightly longer than this first one right here, and it's going in a 90-degree direction, whereas the first one was going in a 60-degree direction. So these two vectors, what we want to do is we want to add them together. And recall that when you add two vectors, at least visually, what we are doing is we're stacking them head to tail. So I might take this longer, the two vectors here, and kind of slide it up, and I would say, well, if it's slid up to this one's head here, or tail, okay, yeah. We got this sliding up here, we would say, well, then where's the resulting vector? And we say, of course, that the resulting vector goes from the initial point all the way along this here and across this here to this terminal point out here. So what we're going to be solving for essentially is this. We want to, I'm going to try to sketch this in as best I can here. We want to find this green resultant vector, and of course the resultant vector that is in green here is just the sum of u and v. That's all that is, okay? And so I might call this new, it's a green vector, I'll call it w. So what we need to do here is we need to write the component forms for u and v and then add these things together. So essentially in this first instance we have 4 is the magnitude and 60 is the angle. So for vector u, we are going to write that its components are these: 4 cosine 60, 4 sine 60. So you can see how easy it is to write component form knowing these two things, the magnitude and the direction. We say v, it's going to be slightly different. It's going to be 5 units in length, and we have cosine of 90 degrees, and we have 5 sine 90 degrees. Now I try to choose convenient angles here so that we wouldn't have to use a calculator, but certainly you could get decimals for all these values. It's just that we know that, or I hope we know, that the cosine of 60 is a half. So we have 4 times a half, and then this is going to be 4 times, and this should be root 3 over 2. And they're both positive, and that's because 60 terminates in the first quadrant. Everything's positive in the first quadrant, all things. So now we have a final component form of this. I would say is 2 comma, and this 4 and this 2 would cross cancel. This become a 2, so we have 2 root 3. Let me try to sketch this out a little bit better. Okay, so this is our component form for our vector u. We need the component form for our vector v. We say that the cosine at 90 degrees, well, the cosine at 90, if you were to go up here on the unit circle, of course, we have the point 0, 1, but the cosine is 0. So we get, we get this. We get 5 times 0, and then 5 times the sine at 90. Well, the sine value is 1. So we get that this is the vector 0, 5. Now, I hope at least you know that looking at this vector to begin with, well, obviously this terminated as 0, 5. I mean, knowing what we know. But we could have found this also using this method for finding component form of vectors. So what we wanted to do was find the sum of these two vectors. We say u plus v. And so if I'm going to find vector u plus vector v, I'm really going to add these in component form. We have 2 comma 2 root 3 plus now 0 comma 5. And so if we were to sum these together, we would get 2 plus 0, which would be, I'm gonna write this out, 2 plus 0, and then 2 root 3 plus 5. And so what this simplifies out to be is this 2 comma 2 root 3 plus 5. So now, here's the thing. I want you to be getting an exact value. This is the best practice here. But we say also underneath this, I don't think it's a crime to actually convert this, at least this y component here, to a decimal. So we know it's 2 comma something, but we just don't know what that other something is. So we see the square root of 3 times 2 equals, add another 5 on there, you get about 8.46-ish. So we get 2 comma 8.46-ish. And the thing that I want to say about this is approximate value, is that when you look at this visual diagram up here, and we say that this vector here, we found its components were 2 and then 2 root 3, technically. And we say that this one here, its components are 0 and 5. When you add those together, I mean, what would this point be up here? And to imagine that it would be 2 comma something is entirely reasonable looking at what we have here, this diagram. And then to say 2 comma what? Well, notice that this goes up 5 in the air, and we stack that on top of something that was already 2 root 3 up into the air. So this total distance here would be the 2 root 3 plus this other 5. So this makes entirely perfect sense. So we just want to be able to now, given directions and magnitudes, write the component form of a vector, and then we can just sum them together. We can do it numerically, we can do it using operations with vectors, and we can do it visually by stacking them head to tail. Cheers.